Welcome back. In this teaching video, I'm looking at 2.2 modulus and argument. 2.2 represents chapter 2, section 2 of the Core Pure 1 textbook. Let's have a look at the key facts of this section. Consider the complex number z equal x plus yi. The modulus of z is the distance from the origin to z. The modulus of z is denoted by z with the two lines on the outside, and it is defined as the modulus of z is equal to square root x squared plus y squared. Have a look at this argand diagram. The horizontal axis represents the real axis and the vertical axis represents the imaginary axis. The complex number z is represented by the point xy. This point over here is called the origin. Now this part of the triangle has the 90 degree and the angle theta. It is represented by x. This part of the triangle is called the opposite and it is represented by y. Theta is the angle between z and the positive real axis and it is denoted by arg z. Now arg z is a shorthand for the argument of z, the angle created between the complex number z and the positive real axis. Have a look at this triangle over here. So we have the adjacent, which is represented by x, and the opposite represented by y, and we've got the angle theta. To work out tan theta, we take opposite over adjacent, so y over x. Hence theta is equal tan inverse of y over x. Now arg z is defined as theta, which is the tan inverse of y over x. Now in A-level mathematics, we'll be looking at angles measured in degrees and radians. Now the argument of a complex number is always measured in radians. Key fact, 2 pi radians is equal to 360 degrees. So we can divide both sides by 2 and we can write down that pi radians is equal to 180 degrees, etc. The principal argument arg z lies in the interval arg z has to be more than minus pi but less than or equal to pi. Here is my argand diagram. So 0 is measured from the positive real axis, so that's 0 there. If we go anti-clockwise, we are measuring positive angles, and if we go clockwise, we are measuring negative angles. So starting with 0, if I go anti-clockwise, this is pi over 2, this is pi. Starting with 0, if I go clockwise, this is minus pi over 2, and this is minus pi. These are the key facts of 2.2 modulus argument. I'll be implementing these key facts within exam style questions. Here is an exam style question. Z is equal to minus 1 minus I square root 3. Find part A, the modulus of Z. So let's have a look at the solution to part A. So in part A, we've got that the complex number Z is equal to minus 1 minus I square root 3. To work out the modulus of Z, we take square root minus 1 squared plus minus square root 3 squared. So the modulus of Z is equal to 2. Let's move on to part B of the exam style question. So in part B, we want to work out the modulus of Z over Z star. So I've got that Z is equal to minus 1 minus I square root 3. Z star, the complex conjugate, is equal to minus 1 plus I square root 3. So now I need to work out Z over Z star. So that would be minus 1 minus I square root 3 over minus 1 plus I square root 3. Now to remove the complex number in the denominator, I need to multiply top and bottom of this fraction by minus 1 minus I square root 3. Now minus 1 minus I square root 3 is the complex conjugate of minus 1 plus I square root 3. So I'm going to simplify this. In the numerator I've got minus 1 minus I square root 3 multiplied by minus 1 minus I square root 3. All over, in the denominator I've got minus 1 plus I square root 3 multiplied by minus 1 minus I square root 3. Let's expand the numerator. So minus 1 multiplied by minus 1 is just 1. Minus 1 multiplied by minus I square root 3 is just going to be plus I square root 3. Minus I square root 3 multiplied by minus 1 is just going to be plus I square root 3. And then minus I square root 3 multiplied by minus I square root 3 is plus 3I squared. All over. In the denominator we have a difference of 2 squares, so we can quickly simplify this into minus 1 squared minus I square root 3 squared. Okay, so let's simplify the numerator. I've got 1 plus 2 lots of square root 3I, and then I've got 3 multiplied by negative 1. So I squared is equal to negative 1. And then in the denominator, I've got minus 1 squared, which is 1. And then minus I square root 3. If you square that, you get 3I squared. So in the numerator, I've got 1 plus 3 times negative 3. So that would be 1 minus 3. Minus 2. And then we've got plus 2 square root 3I all over. I've got 1 minus 3 multiplied by negative 1. So that would be 1 minus 3, which is 4. So I've got minus 2 plus 2 square root 3I over 4. And then if I split this into two fractions and simplify, I get minus a half plus a half square root 3I. Now I can take the magnitude, or you could say the modulus of z over z star. So the modulus of this one here. Modulus of z over z star is equal to square root minus a half squared plus a half square root 3 squared. So if I put this into my calculator, I get precisely 1. This completes part A and B of the exam style question. Moving on to part C of the exam style question. So in part C, we want to first find arg z. Okay, so part C, we're going to begin with arg z. The complex number z is given by minus 1 minus I square root 3. Now the principal arg z, we know that it is more than minus pi, but less than or equal to pi. There are multiple solutions for arg z, but we're going to restrict it within this particular interval. Now my next step is to represent this complex number on an argand diagram. So here is my argand diagram. I've got the real axis, I've got the imaginary axis. Here is the origin. So the complex number z will be somewhere over here. And as a point, that would be minus 1 minus square root 3. We have 0 radians here. If I go anti-clockwise, this is pi over 2 radians. This is pi radians. If I go clockwise, this is minus pi over 2 radians, and this is minus pi radians. So I want to work out arg z. I'll represent it on the complex diagram. This is the angle that looks like that. So arg z. Now before we work out arg z, let's call this angle here alpha. Okay, we're going to drop a perpendicular to the horizontal axis. So I'm going to create a right angle triangle. So here is my right angle triangle. Now remember, for a shape, all the sides have to be positive. Since this point has coordinate minus 1 and minus square root 3, that part of the triangle represents the positive of the x coordinate, so it will just be 1. And that part of the triangle represents the positive of the y coordinate, that will just be square root 3. And this angle here is alpha. So we know that tan alpha is equal to opposite over adjacent, so square root 3. Now I can work out alpha by taking tan inverse of square root 3. Okay, so if I do this, I get alpha is equal pi over 3. So this angle over here, the arg z, is given by minus pi plus the pi over 3. That would just be minus 2 pi over 3. So the argument of z is minus 2 pi over 3. Okay, so I've calculated arg z, and now I'm going to calculate arg z star. The complex conjugate of z, denoted by z star, is given by minus 1 plus I square root 3. The principal argument of any complex number, so in this scenario, the principal argument of z star, denoted by arg z star, will be more than minus pi, but less than or equal to pi. Now, of course, we know that arg of z star has multiple solutions, but we are going to restrict it within this interval. I'm going to represent the z star on an argand diagram. So here is my argand diagram. I've got the real axis, I've got the imaginary axis. This is the center O, the origin. The complex number z star looks something like this. So the point as a coordinate will be -1 square root 3. I've got 0 radians here. If I go anti-clockwise, I'm measuring positive angles. So that part will be pi over 2 radians. And that part will be pi radians. If I'm going clockwise, I'm measuring negative angles. So this part over here will be minus pi over 2 radians. And this will be minus pi radians. So to work out arc z star such that it falls within this interval, I need to calculate this angle here. Arc z star. Now before I work out arc z star, I need to find this angle here. Let's call it alpha. I'm going to drop a perpendicular to the horizontal axis. So I've created a right angle triangle. Let's have a look at the right angle triangle in more detail. So this side is basically the positive version of this x coordinate. It is 1, and this side over here will just be square root 3. So from the triangle, to work out tan alpha, I need to do opposite over adjacent, so that will be square root 3. For alpha, I take tan inverse of square root 3, and this will give me pi over 3. So to work out arc z star, we know that this entire angle is pi. I must do pi take away the alpha. So pi take away pi over 3. This will give me the argument of z star. So the answer will be 2 pi over 3. Okay, so finally we want to work out argument of z over z star. Okay, so let's proceed forward. From part B, we know that z over z star is given by -1/2 plus 1/2 square root 3i. The principal argument of any complex number, so in this scenario, the principal argument of z over z star is denoted by arg z over z star, and it has to be more than minus pi, but less than or equal to pi. Again, there are multiple solutions, but we're going to restrict it within this interval. Now I'm going to represent this complex number on an argand diagram. So here is my argand diagram. The horizontal axis is the real axis, the vertical axis is the imaginary axis, and this is the center O, the origin. -1/2 plus 1/2 square root 3i will be somewhere over here, that point there. So that represents z over z star, and as a coordinate it will just be -1/2 and 1/2 square root 3. Okay, right, so this is 0 radians. If you go anti-clockwise, positive angles, this will be pi over 2 radians, and this will be pi radians. And if you go clockwise, negative angles, this will be minus pi over 2 radians, and this will be minus pi radians. So the argument of z over z star is basically this angle over here. Okay, so we want that angle to be within this interval, and precisely you can see that it is between minus pi and pi. So we can denote this by arg z over z star. Now to find this angle, I'm going to first work out this angle. Let's call it alpha. Drop a perpendicular from the point z over z star to the horizontal axis. Create a right angle triangle. So I've got a right angle triangle. This side over here is the positive of that negative x coordinate, so it will just be 1/2. And this side over here will just be 1/2 square root 3. From this triangle, we can see that tan alpha is equal to 1/2 square root 3 over 1/2, which is just square root 3, opposite over adjacent. Alpha is equal tan inverse of square root 3. So alpha is equal pi over 3. Hence, to work out the argument of z over z star, which is this angle here, we have to do pi take away the alpha. So pi take away pi over 3. Again, that is 2 pi over 3. So arg z over z star is 2 pi over 3. This completes the first exam style question. Here is another exam style question. The complex number w and z are given by w equal k plus I and z equal -4 plus 5ki, where k is a real constant. Given that arg of w plus z is equal to 2 pi over 3, find the exact value of k. Let's have a look at the solution. Now, I'm going to first start by working out w plus z. So w is k plus I, plus z, which is minus 4 plus 5ki. So I'm going to collect the constants and the items. So I've got k minus 4. I can put a bracket around it. That is my real number. And then I'm going to collect the i's. So plus I plus 5ki. There's a common factor of I between these two terms. I can factorize this. So my real number is k minus 4 plus my imaginary number in factorized form will be 1 plus 5ki. So in the question we are told that arg of w plus z is equal to 2 pi over 3. We know that the principal argument of w plus z has to be more than negative pi but less than or equal to pi. This is the interval that we're going to look at. Now I'm going to represent arg of w plus z, which is equal to 2 pi over 3, on an argand diagram. So here is my argand diagram. Real axis, imaginary axis, the origin, O. Okay, so the angle 2 pi over 3, we're going to represent it on the argand diagram. We know that this is 0 radians. If we go anti-clockwise, positive angles, this will be pi over 2 radians, and this will be pi radians. If I go clockwise, negative angles, this will be minus pi over 2 radians, and this will be minus pi radians. So 2 pi over 3 will be an angle that looks something like this. So that 2 pi over 3 is basically the argument of w plus z. So my complex number w plus z has to be in the second quadrant. Okay, so this is my complex number w plus z. So as a coordinate, I can write the x coordinate as k minus 4 and the y coordinate as 1 plus 5k. I'm going to drop a perpendicular from that point to the horizontal axis. Let's call this angle alpha. Okay, so now I can draw a right angle triangle. Here is my right angle triangle. This side of the triangle is the positive x coordinate of that negative x coordinate k minus 4. To make that negative x coordinate k minus 4 positive, I need to put k minus 4 in bracket and stick a negative at the front. And this side of the triangle will basically be 1 plus 5k. So from the triangle we can see that tan alpha is equal to opposite of adjacent. The opposite is 1 plus 5k over the adjacent, which is minus 1 lots of k minus 4. Okay, opposite over adjacent, GCSE mathematics. Okay, so if this angle over here is 2 pi over 3, the alpha has to be pi minus 2 pi over 3. So the alpha will just be pi minus 2 pi over 3, which is pi over 3. So I can substitute the alpha back into this equation. I've got tan pi over 3 is equal to 1 plus 5k over negative 1 lots of k minus 4. Now tan pi over 3 is square root 3. So I've got square root 3 is equal to 1 plus 5k over negative 1 lots of k minus 4. I'll take this denominator to the left hand side. So minus square root 3 in bracket k minus 4 has to equal 1 plus 5k. Expand the bracket. And now we have to make k the subject. Okay, so I've got 4 square root 3 minus 1 is equal to 5k plus square root 3k. So I'll take the solution. Over here I'll continue. I've got 4 square root 3 minus 1 equal to There's a common factor of k between these two terms. I can factorize this. And so inside the bracket, I've got 5 plus square root 3. Now I can make k the subject. So k, the exact value, is equal to 4 square root 3 minus 1 over 5 plus square root 3. And that completes the exam style question and this teaching video 2.2 modulus and argument. If you found this teaching video useful, please don't forget to subscribe, leave a like, leave a comment, turn on your notification bell so that you receive notifications every time I post a new teaching video.